Hello! Thanks for being part of my instructional channel about seismic waves. So you just watched a movie that shows the propagation of a wave in elastic isotropic media. In this video today, we will define the elastodynamic objects, which are displacement, strain, and stress, and we will also identify the laws that govern the elastic wave equation. Sounds good, right? So let's go. First, it's important to discuss what are the assumptions we make when we work with the elastic wave equation. So we consider that the material is continuous, elastic, and isotropic. When the material is continuous, we can calculate derivatives. Good, right? When it's elastic, it means that our deformations are small. And by assuming it's isotropic, we make things easier because the physical properties, they don't depend on direction or position. Sounds good too, right? So now let's identify our elastodynamic objects. Number one, displacement, which we will represent as the vector U. So displacement characterizes the vibrations and the change in position of a volume. Number two, stress. Stress is a symmetric tensor represented as T, and as it's a tensor, we are putting the stress under the T. And stress characterizes the force applied to a material. And number three, finally, we have strain. So strain is also a tensor, and we will represent this as E. So strain characterizes the deformations under stress. So yes, it seems that we have just identified the three elastic dynamics objects. So repeat with me: displacement, strain, and stress. The elastic wave equation plays with the relationship among these elastic dynamic objects. So now we will see how these objects are connected. First, let's talk about the geometric law. The geometric law links displacement and strain and represents geometric properties such as deformation. Now we link stress and strain, and we have the constitutive law. This law determines how strong or weak a rock is depending in relation to its physical properties. So for the constitutive law, we use the stiffness tensor, represented as the tensor C, to link stress and strain. So the stiffness tensor characterizes the elastic properties. Finally, we will link now displacement and stress. They are linked by the equation of motion, which also bring us knowledge about time and density. Well, we just identified the three laws that govern the elastic wave equation, which are the geometric law, the constitutive law, and the equation of motion. So for next video, we will apply this law we learned today in order to derive the elastic wave equation. I hope to see you there.